Good morning, dear students. Now we are moving into the third unit, kinematics of cam mechanism. In kinematic of cam mechanism, we have been seeing so far simple harmonic motion and uniform velocity and uniform acceleration retardation. Now in this problem, we are going to see the uniform acceleration and retardation for inlet valve opening and closing. Okay, what is inlet valve opening and closing? In an IC engine, there are two valves. One is inlet valve, the other one is outlet valve. We are using the cam mechanisms for opening and closing the valve or opening and shut off valves. Those mechanisms are followed by either roller follower or knife edge follower or flat surface follower due to the requirements and their usages. Normally, if they use those cam mechanisms, they may be using different follower mechanisms or different velocity or displacement diagrams. Those diagrams are belonging to the simple harmonic motion, uniform velocity or uniform velocity or retardation, or otherwise they can use cycloidal motion. Cycloidal motion also they can use for the cam mechanisms. In this problem, we are going to see uniform acceleration and retardation. Okay, now we will move on to the problem. Please take down the problems. Design a cam for operating the exhaust valve of an oil engine. We can use it for oil engine purpose also. That's what this problem is given. Design a cam for operating the exhaust valve of an oil engine. It is required to give equal, uniform and acceleration and retardation. This is uniform velocity, and these are the accelerations and these are the retardations. That's what it is given in the problem. During operating and closing of the valve, this is used in opening and this is used in closing. That is what it is given here of the valve which corresponds to 60 degree of cam rotation. Normally the cam will rotate 360 degree. The complete circle the cam rotates. See, this is how the cam profile rotates, and that is what is said. First 60 degree it opens and then it remains dwell. Dwell means the motion is complete rest. The motion which is under complete rest is called as dwell. And again it closes or return stroke. We can say this as closing stroke or return stroke. Both are correct. And once again this will leads into dwell, which will be the cam will be under rest. That is what the meaning gives. Okay. The valve must remain in fully open position. The valve should be open fully in this position, in this 60 degree. That is what it is said there. For 20 degree of cam rotation, see the valve will be open during the 60 degree and it will remain open. That is what well means the cam will open during the stroke and it will be let open. And after 20 degree only the cam retards or closes or comes back to its original position. That is what given here. The lift of the valve is 37.5 mm. The height of this is 37.5 mm. It is what given here. And the least radius of the cam is 40 mm. This least radius is 40 mm. This is the least radius. This pink color is the least radius. Sorry, this circle is the least radius. Base circle is radius is 40 mm. That is what given here. The follower is provided with the roller of radius 20 mm. This roller radius is 20 mm. We should take in the compass as 20 mm and we should place the center point here and we should draw the circle. That circle should touches this base circle. Okay, this base circle should be engaged. For that, we should draw another circle. First, we should take the radius as 40 mm by placing the compass here. We should draw the circle. Again, by taking radius as 20 mm. Again, we should take the radius as 20 mm and we should draw this circle. So that if you take the radius as 20 mm, this circle will touch this point. That is what it is said there. And the line of stroke passes through the cam axis. Line of axis passes through the cam axis means the follower remains as such. If the line of stroke is said to be 10 mm away from this or 20 mm away from this, that is offset. That is called as offset position. Okay, now we are clear. Okay, coming back to the displacement diagram, we should draw the displacement diagram. For first we should draw a horizontal line. The horizontal line should be up to 360 degree. You can take any scale ratio. In this problem, first we should look into the problem. They are saying that 60 degree the opening and closing is 60 degree. They said that the opening is 60 degree and closing is 60 degree. What they are saying, the remaining the wall should be open for 20 degree. That is the condition given here in this problem. First you should fix O point. First you should draw a horizontal line and the height of the line should be 37.5 mm. Correctly it should be 37.5 mm. You should draw a vertical line and horizontal line you can draw for some value. Okay. Now you should convert the scale ratio as 60 degree. They said so 60 degree means you should draw 6 centimeter line and 20 degree means you should draw 2 centimeter line and once again 60 degree you should draw further 6 centimeter line and a rectangle will be formed. See 37.5 mm height and from here totally 14 mm distance you should draw. First 6 centimeter is outward stroke and next 22 centimeter is well and remaining 6 centimeter is return stroke. So the rectangle will be formed and you should connect these points as such and you should separate this into 3 divisions. First division is 60. After 6 centimeter you should draw a vertical line and the dwell will be 2 centimeter, that means 20 degree. You should draw a vertical line and once again we should draw a vertical line after 6 centimeter, that is 60 degree and remaining portion you can draw to as much you wish, or as much in your drafter, as much in your drawing sheets it permits, and you should draw it as such. Now you should draw vertical. You should segregate this into 6 divisions. See, we should mark the point 1, 2, 3, 4, 5 and 6. You should divide this into 6 equal parts. You should divide this into 6 equal parts, and you should draw the vertical lines. And once again, that you need not draw anything. And coming to this, once again you should divide into 6 equal parts. 1, 2, 3, 4, 5, 6. 6 equal parts you should divide. And you should draw the diagonal which connects this 60 degree, top of this 60 degree and bottommost point of this 0 degree, from where we have where I have started the point, and you should draw the diagonal. And remaining 12 position, and you should draw the diagonal from here, the H point, till